Anyone with the answer? Latushan? Neola, what is the answer? And also missing. Kaushika, what is the answer?
I have no clue.
Good. Harry. So, are you okay with the titrations that we have done with KMnO4? KMnO4 means MnO4 minus. We did 2 titrations with Fe2 plus and with C2O4 2 minus. Ratio is 1 to 5. Here, 2 to 5. In both cases, color change will be colorless to first permanent pink if you are adding MnO4 minus from the burette. Right. This can be either Fe2 plus or C2O4 2 minus. It's happening. Now, in this question, the thing is, you have both the ions, FeC2O4. Both the ions are there, right? Both the ions are there. Therefore, in the titration or in the calculation, you have to consider the total amount of manganate that react with Fe2 plus as well as C2O4 2 minus. So you have to consider the first case, or like reacting with Fe2 plus as well as the MnO4 2 minus. So now, to react with the let's take the complete molecule. You have FeC2O4 and you have Fe2 plus is there and C2O4 2 minus is there. To react with one mole of FeC2O4. In the case, if you are having 1 mole of C2O4, you have 1 mole of Fe2 plus and 1 mole of C2O4 2 minus. Is this clear? In 1 mole of FeC2O4, you have 1 mole of Fe2 plus and 1 mole of C2O4 2 minus. To react with 1 mole of Fe2 plus, you need 1/5 of MnO4 minus, because the ratio is 1 to 5. Is that clear? In other way, I can say, make it in 5 mole to react with 5 mole of, in 5 mole of FeC2O4, you have 5 of Fe2 plus and 5 of C2O4 2 minus. To react with 5 moles of Fe2 plus, you need 1 mole of MnO4 minus, because the ratio is 1 to 5. Is this clear? At least you can use the raised hand option, right? So you have 1. To react with 5 mole of C2O4 2 minus, as I told you earlier, you need 2 moles of MnO4 minus. අත උසන් ඉන්න බෑ අතරේ දෙනවා. මාරු උත්තර තමයි දෙන්නේ. Okay, good. Now, is this clear? First, you should know what is the ratio between Fe2 plus and MnO4 minus, sorry, and the ratio between C2O4 2 minus and MnO4 minus. Therefore, if we consider 5 mole of FeC2O4, you have 5 mole of Fe and 5 mole of C2O4 2 minus. To react with 5 mole of Fe2 plus, you need 1 mole of MnO4 minus, as well as to react with 5 mole of C2O4 2 minus, you need 2 moles of MnO4 minus. Therefore, to react with 5 mole of this compound, you need 3 moles of MnO4 minus. Is this clear? Or not? Before going to do the question, you have to work this out. If you can work this out, then that's the answer. Again, is this clear, Lamai? Hands up that who want to explain this again? Nathan, just tell me. Kaushika, Harshani, Hevani, Latushan, Mimesh, Niola. Is this clear, Sasnima? Is this clear?
Oh, excuse me, sir. Can you explain it again, please?
Ah, right. Okay. I'll explain again. Okay. Now, what I'm doing is discussing the homework. Last week, I gave you only one question, only a question, right? So this question is about titration between potassium manganate and FeC2O4. FeC2O4. In FeC2O4, you have Fe2 plus and C2O4 2 minus ion. Right? To react with 1 mole of FeC, we got the ratio Fe2 plus to MnO4 minus ratio is 1 to 5. 1 to 5. And the ratio between C2O4 2 minus to MnO4 minus is 2 to 5. This is what we have discussed in the last week. The ratio 1 to 5 and 2 to 5. Right? Therefore, you can say, if we take 5 mole of FeC2O4, you are having 5 mole of Fe2 plus and 5 mole of C2O4 2 minus. To react with 5 mole of Fe2 plus, you need 1 mole of MnO4 minus. And to react with 5 moles of C2O4 2 minus, you need 2 moles of MnO4 minus. So altogether, to react with 5 mole of this FeC2O4, you need 3 moles of MnO4 minus. Then is this clear? Or not?
I understood, sir.
Others? Hands up who want me to explain this again another time. I can do it. Okay, perfect. All right. Now we have the ratio that is 3 to 5. You can simply do the question. Now, FeC2O4 to KMnO4, the ratio, not minus, sorry, there's no minus. KMnO4 ratio is 5 to 3. Then the first part, number of moles of, we have to find the volume of KMnO4 that reacted. Therefore, we can find the moles of FeC2O4. Mass is given. So the moles will be 1 divided by 143.8. That's the number of moles of FeC2O4. Therefore, the moles of KMnO4 will be 1 divided by 143.8 times 5/3. Now, if you know the moles, you can simply use the N equals CV equation, right? And you can subject V. V is the number of moles divided by the concentration. So, can anyone tell me the answer for this number of moles? And the concentration is 0.02, and you can get the volume in DM3. Now, can you tell me the answer for this? So 0.209 DM3 is the answer. Or else you can say it's 209 cubic centimeters. Shall I erase? I assume that you are done with this, so I'm moving to the next one. So we have done 2 titrations already, right? And the next type of titration is iodine thiosulphate titration. Wait, did we discuss this practical? Finding the moles of water of crystallization? Anyone? Did we discuss this one? Ayyo. Pranav, what do you think? Did we discuss this practical? Latushan? Kaushika? Yes, thank you. So all the titration with MnO4 is done. Now the next topic is redox titration with iodine and sodium thiosulphate. This is the topic. And these are the two main equations, and this is the final equation. Just copy this one. So what we have to do is redox titration with iodine and sodium thiosulphate. And these are the equations. I think I have explained you about this titration. The color changes and all. In this titration, the indicator is starch. You are adding starch to the iodine solution. So usually the thiosulphate is in the burette and the iodine solution is in the conical flask. Iodine is brown in color when dissolved in the aqueous solution. So when you add thiosulphate, brown color of iodine become paler, right? And the color change without an indicator will be pale yellow to colorless. Pale yellow color of the iodine will disappear and the endpoint will be pale yellow to colorless. But the thing is, it's very difficult to identify that point where the pale yellow solution goes to colorless. Therefore, in order to make the color change clear, you have to add starch. So the indicator for this titration is starch, and the starch will not be added at the beginning of the titration. If starch is added when there is high concentration of iodine, iodine will form insoluble complex with starch. Therefore, how many, like what volume you added to the solution will not give any change in color because the starch iodine complex is insoluble. Therefore, you have to add some amount of thiosulphate. That means until the solution become pale yellow, and then you can add the starch, and then you can see the clear blue-black color. And once you added few more drops of, or sometimes one drop or two drop can be of thiosulphate to the blue-black solution, it eventually goes to colorless. So that's the color change. So the color change is blue-black to colorless. But you should know why you are not adding starch at the beginning. What is the point, at what point you have to add the starch, and then what is the color change. And why can't you do the titration without starch? Is that clear? Okay, let's write then. This titration is used to direct estimation of iodine, direct estimation of iodine, direct estimation of iodine, or to estimate the substance that can take part in a reaction that produces iodine. That means in some reactions, it produces iodine. So from that, you can find the amount of iodine. From that ratio, you can find one of the reactant that produces iodine, and so on. You can do the calculation, right? So two uses. Number one, direct estimation of iodine, or to estimate estimation of a substance that can take part in a reaction that produces iodine. So I'll show both the calculations. Important. Indicator for this titration is starch solution. Starch produces blue-black color with iodine. Blue-black color with iodine. And as soon as excess sodium thiosulphate has been added, blue-black color disappears to form colorless solution. Next point, starch should not be added at the beginning of the titration because starch should not be added at the beginning of the titration because starch will form insoluble complex. Starch will form insoluble complex with iodine. Without adding starch, it's difficult to detect the endpoint. Because the color change is pale yellow to colorless. Which cannot be determined easily. In order to determine the endpoint accurately, starch should be added. When the solution becomes pale yellow. That's it. Any doubts in iodine thiosulphate titration? Okay, then. Next topic. First type of titration, determine the percentage of copper in determine the percentage of copper in a sample. Okay. Okay, we have to copy this. This is one of the practical that they are in the lab book as well, right? But anyway, let's. Oh, I'm sorry. Okay. Just the practical. This part. Copy this one. This part will not be needed. right now in this titration, what we are going to do is you are going to analyze the amount of copper 2 plus present by iodine, right? The iodine that produced. So what will happen when you add I minus, iodide iron to copper 2 plus, it produces copper 1 iodide and iodine. Copper 1 iodide and iodine. This produced iodine then can be titrated with thiosulphate. So here you already wrote the iodine thiosulphate equation for the iodine thiosulphate titration. Iodine to thiosulphate ratio is 1 to 2. So from the moles of thiosulphate, you can find the moles of iodine. If you know the moles of iodine, then you can find the moles of copper 2 plus. That's how you continue to do the calculation and find the amount of copper 2 plus present. Is this clear? And remember, in this particular titration, thiosulphate to copper 2 plus ratio is 1 to 1. Okay, right. Now here the experimental procedure is given. Weigh accurately using a weighing bottle, approximately 6 grams of hydrated copper 2 sulfate crystals. Then transfer to 250 volumetric flask and reweigh the bottle. Remember, this is exactly the correct way of measuring a mass. Initial mass of the container with the solid and then final mass of the container without the solid. The difference gives you the amount of the solid added. And then the sodium carbonate solution, you add in sodium until the slight permanent bluish precipitate of copper 2 carbonate form. And then you are adding dilute ethanoic acid until you dissolve the carbonate and you have the copper 2 plus only. And then you are going to volume up to the mark 250, and then you are only taking out 25 cubic centimeters and you are adding solid potassium iodide. So to add it, taken 25 cubic centimeters of copper 2 plus for that particular 25 cubic centimeters, only you are adding 1.5 grams of potassium iodide. And then you are going to titrate and find the amount of iodine produced using the thiosulphate. And you can repeat and obtain the concordant results. Is the experiment clear? Right. Now let's note down the procedure as well. Remember, always you have to repeat the titration in order to obtain the concordant results. Just let me know if there's anything that is not clear to you. Finish writing? Right. Now, our target is to calculate the percentage of copper 2 plus ions in the hydrated copper 2 sulfate crystals. Right. The sample results are given to you. So what we have to do is we have to calculate the percentage of copper 2 plus in a sample of hydrated copper 2 plus crystals. And these are the sample results. Okay. Quickly take down the results. Right. So as I told you, you are titrating the produced iodine with thiosulphate, and iodine is produced from copper 2 plus. So the ratio between copper 2 to iodine is 2 to 1, and iodine to thiosulphate is 1 to 2. So the ratio between copper to thiosulphate will be copper 2 plus 2 thiosulphate. Ratio is 1 to 1. So first, as the first step, we can find the moles of sodium thiosulphate. You can find the moles of sodium thiosulphate. Moles of Na2H2O3, that is 0.0995 into 23.45 divided by 100. Sorry, 1000. And this number of moles will be same as therefore moles of copper 2 plus, same number of moles. To the power -3. If you can remember, we have taken this copper 2 plus only in 25 cubic centimeters, moles of copper 2 plus in 25 cubic centimeters. Therefore, the moles of copper 2 plus in 250 cubic centimeters will be, you have to multiply this by 10. 2.33 into 10 to the power of -2. Then the mass of copper, or the copper 2 plus will be same then at the end. 2.33 into 10 to the power -2 into 63.5. Can anyone tell me the mass of copper after the calculation? Grams. And the percentage is 1.48 into 5.85 into 100, so 25.3. Right, done. Any doubts on that calculation? Okay, do the question number 5. This question. Bella. Oh. Haushika, Evani, Latushan, Mivesh, Neola, Pranav, and Sasnima. You must send me the answers. Right. I got only one answer. When bleaching powder react with dilute acid, chlorine is produced. This chlorine is available for bleaching and is known as available chlorine. A 2.5 grams of sample of bleaching powder is added to an excess of potassium iodide solution, and the mixture is then acidified. The solution is placed in a volumetric flask made up to 250 with the ionized water. 25 of volume of this solution required. 23.2 of sodium thiosulphate to oxidize the iodine present. Right. Calculate the percentage of available chlorine. Great. 2.5 bleaching powder is there, and you are making a solution of 250. From that, you are taking only 25 out, and that one you are going to titrate. Right. Here we go. First step, you can find the moles of sodium thiosulphate. Good. Moles of sodium thiosulphate. That is 223.2 into 0.105 divided by 1000. Right. And 2.436 10 to the power minus 3. Ten to the power of minus 3. And iodine to thiosulphate 2 to 1. Yeah, for the moles of iodine, and the moles of iodine will be same as the moles of chlorine, or you can say moles of chlorine in 25 again. Remember this dilution factor. Always you people are keep on forgetting to include this dilution factor 25, right? 25. 2.436 into 10 to the power of minus 3 divided by 2. 1.218 10 to the power of minus 3. And this amount is present in 25, now therefore moles of chlorine in 250 is 1.218 into 10 to the power of minus 2. Then you know the moles, therefore the mass. So 71. So it's only 0.865. Therefore, the percentage is 2.5. So I'm getting 34.6 as the answer. Is this clear? You might have identified the mistakes as well. Okay, do the question number 6 as well. Remember, these 6 questions in this page will be very important. Now you know the mistakes. No? Okay. likely ionic equation for this reaction, please? Ah, yes. What is the ratio? At least, can you tell me the ratio then? It's 1:2 ratio. You do that. No problem with that. So you can find the moles of thiosulphate. 21. Minus 3. And here the moles of the same number of moles. And looks like same. 25 into minus 4. Okay, so this is the moles of thiosulfate. Now the moles of iodine will be 5.25 into 10 to the power of minus 4 again, because divide by 2. And you may notice that the iodine moles and the K2S2O8 moles are the same. Therefore, the ratio between these two will be 1:1. Right? Therefore, the likely ionic equation for this is S2O8 2 minus will produce 1 iodine. Therefore, 2i minus should be here. And you can write whatever the derivative of this SO4 2 minus like that. That is the answer. So we just use the molar ratios and we have identified the molar ratio between this one and this one is same. So with the help of that, I made the full equation. Is that clear? No one is talking. Is this clear? Thank you, thank you, thank you. Okay, one last question and another tricky question. Therefore, be careful. That is question number 4. I advise you to practice these 6 questions again and again. Question number 4. Read well, read well. Lamai, listen, you have to answer this. If you are not practicing during even in the class, like you find some difficulty to answer this question in the paper. Therefore, at least try to write something and at least try to find the moles of the species that you are able to find, right? Just do it. Then it will automatically work for you. Yes. Anyone with the answers? Yes, yes, I know, I know, I know. That's why you must try this. You have an aqueous solution with iron 2 and iron 3. First, you are adding sodium thiosulphate, sorry, potassium manganate to this mixture. So you only required 21.6 into 0.021 divided by 1000 moles. Right. Now, if we are going to react this mixture with the potassium manganate, will Fe3 plus react? What do you think? Yes or no? Will Fe3 plus react with KMnO4? Give the answer based on your knowledge. Will KMnO4 react with Fe3 plus? Kaushika, what do you think? It should either be yes or no. Nothing else. Latushan? Yes or no? KMnO4 is an oxidizing agent, so it can only oxidize. Fe3 plus is the highest oxidation state, it will not oxidize. Therefore, this will not react with KMnO4. So only Fe2 plus will react with KMnO4 with the ratio of 5 to 1, the same ratio. So from these, you can find the moles of Fe2 plus. This answer 21.6 into 0.021 divided by 1000 and that answer into 5. That's the moles of Fe2 plus. And wait, one is telling me the answers. No, I have to find the answer as well. into 10 to the power of minus 3. Yes, thank you. In the second case, what they are doing is they are adding zinc to the mixture. Right? And it says that iron 3 will be reduced to iron 2. Now, after you add zinc, you have only Fe2 plus, no Fe3 plus remains. Right? And this Fe2 plus then react with KMnO4. Now this time you need 44.4 and the same concentration. Why? Can anyone tell me why the volume of KMnO4 has increased this time? What's the reason for this? 44.4. Why the number of moles of KMnO4 increase? The reason is zinc has converted the Fe3 plus also to Fe2. Right? So then we can get the moles of Fe2 plus again as 9.324 10 to the power minus 3 and that answer into 5. Sorry, minus, this should be minus 4. And the answer is 4.662 10 to the power of minus 3. Now I have two answers. Volume is 25, right? Moles of Fe2 plus before adding zinc. 6, 8 10 to the power of minus 3. Therefore, the concentration of Fe3 plus is 25. Then moles of Fe3 plus you can find by subtracting this number from this. 2.394 into 10 to the power of minus 3 and concentration of, sorry, the previous one should be concentration of Fe2 plus. Thank you. And the concentration of Fe3 plus is divided by 25 again. Zero point 0.095 8. Small dm minus 3. These are the answers. Divide by volume, yes. Divide by volume to get the concentration. How is this calculation clear? Has Apu got the correct answer? No one. At least one answer? Fe2 plus concentration. Right. I hope this is it's okay. It's okay. I hope the method that I have explained is clear. This may be a question in the exam. Therefore, get ready. Right. Unit 5, topic 1 is almost over. Right. So, yes. You have to do a lot of practice. Therefore, I'll be sending some more questions so you can practice. We have to do one more topic, that is fuel cells. Right. I think I can finish it within 1 hour. Therefore, by next week, the unit 5 topic 1 is over, and then I'll be starting the next part as well. Right. So that's it for today. Then I will send some more questions. And I thought of coming tomorrow. It's not going to work.